Hi, and welcome back. We are on page 184 talking about the natural base e. So in all the other functions that we graphed and played around with our base, for example, in problems 9 and 11, we used the base of 5. We're going to be talking about the natural base e. There's a link on your Canvas page, that has a great YouTube video, and the young gentleman, college student, is describing why E, where it comes from, and why we use it. And it's very clear and concise, and I think it would help all of you if you had studied that before. What is the significance of E? He goes over it entirely, and it makes it very, very clear. So please go ahead and look at that before you get started here. Natural base E. E is an approximation and an irrational number. And if you remember the definition of irrational, cannot be written as a ratio of one integer to another. I'm trying to talk and write this. This might not be the right. 7, 1, 8, 2, 8, 1. Close enough. Okay, so you guys look that up. The value E, of course, like pi, we're going to be truncating most of the time. When you use your calculator, however, it uses, I don't know out to how many places, but it uses a lot more places than we do when we round it to the nearest hundredth. It says, in example 5, you'll see that the number E can be approximated because, again, it's not a rational number, by the expression 1 plus 1 over x to the x power for large values of x. So if we plug this into our function editor, into our calculator, and look at our table and see what number we are approaching, you would see that as x got larger and larger, we got closer and closer to that value E, 2.7182818828, and on and on and on. Let's look at example 5. It says, evaluate this expression for several large values of x to see what the value is approaching. So at the bottom of page 184, I'm looking at two graphs. On the left-hand side in example 5, it says a graphical solution. It's asked you to place two functions into your function editor. Y1 being the approximation that we just wrote here on the screen, and then Y2 on your calculator. If you have one of the TI-84s, E is a blue function, or the second function above the division sign. So little e is right above the division key. Okay, that's where you'll find it in the last column, right under the arrows. So we want you to graph both of these, 1 plus 1 over x to the x, and E in your second function, Y2, and compare. And you can see as x increases, the graph of Y1 is getting closer and closer to Y2. If you look in your table, which is what example 5 is showing you, use the table feature, and for Y1 increasing values of x from 10, 100, 1,000 by powers of 10, we can see that our Y1 value is getting ever closer to the approximation that we see at the top of 184. And so, at the bottom, they conclude it's reasonable to say 1 plus 1 over x to the x is approaching the value E as x approaches positive infinity. And now I'd like you to try exercise 27 in your problem set. Go ahead and pause this recording, and we'll come back and look at the solution or have a conversation about problem 27. So we can see from example 5, the approximation of E, 1 plus 1 over x to the x. Problem 27 asked you to look at and compare 1 plus 2 over x to the x and compare it to E to the second power. Now, e to the second power, taking our irrational value of e and squaring it, we get 7.39. We've rounded that off. I take the values and didn't show a table, but I plugged them in. I wanted you to see what was going on here, allowing x to be 1, 2, 3, and 4. Substituting that value in for x in our f of x function, we can see the growth start to happen. And what's going to happen as this value 2 and the power of e, we can see this is a straight line or a constant. There's no variable. There's no x value. It's just a constant function. We can see the approximation of e. When we replace that numerator in the fraction, we can see that function start to approach e to that power. On that note, what I'd like you to do is just a quick study. I want you to take the approximation of e, but we're going to change that numerator again. Sorry, that's a 3. 3 over x to the x. I want you to compare that. I think you already know how this is going to play out. Compare that to the function g of x e cubed. And let's go ahead and h of x. Let's say something that fits on our screen. Let's just go with the next one. 1 plus 4 over x to the x power. And compare that to the function q of x e to the 4th. And I think that we'll be able to conclude and be able to verbalize the pattern that we see with these two functions and start to draw greater and more far-reaching generalities. Take a pause right now, look at those two functions, and we'll get back right here.